So in the second part of solving graphically for quadratic functions, we're going to look at a problem and we're actually going to set up an equation for the problem. They don't give us the equation, so we have to do that first. So we're going to read the problem, pick out some key information, and then talk about how we set up the equation. And after we set up the equation, then we'll create a graph and we'll answer some questions. So in this particular question, it says, last season, we had a struggling hockey club who had 7,200 season ticket holders. So that's important to know. It says the owner decided to raise the price of the package of season tickets. We need to know, is the price going up or is the price going down? It says the existing cost of a package of season tickets is $1,400 before he raised the price. And research reported that for every $25 increase, approximately 100 season ticket holders would not renew their tickets. Okay, so some of the things we need to realize here is that the price is an increase in a multiple of 25. So it says in this question, let X be the number of $25 increases in the price. And it says write an expression for the cost of season tickets and the potential season ticket holders. Okay, so first of all, we're going to write an expression for the cost. So the original cost is $1,400, and we're going to be increasing that by multiples of 25. So the X is here because the X is going to represent how many times did we increase it by $25. Once or twice or three times, etc. If we talk about the number of season ticket holders, well, the original number of season ticket holders was 7,200, and that's going to decrease by 100 for every time that we increase the price by $25. So we've got cost and number. So now it wants us to generate an expression for revenue. Well, let's talk about revenue a little bit before we talk about this expression. Revenue is the amount of money you make. And how do you determine the amount of money you make? Well, you take the number of people attending and you multiply it by the price you're charging them. So if we just write a little word equation, revenue is going to be the cost of the tickets multiplied by the number of people who actually buy tickets. So if we're going to generate revenue here, we're going to take 1,400 plus 25x, and we're going to multiply it by 7,200 minus 100x. And we're going to need to expand this. We're going to need to multiply this out. So we're going to have to go 1,400 times 7,200. No, I can't do that in my head. So I'm going to go 1,400 times 7,200, and I'm going to get this big, huge thing. Be careful with the zeros. There's 4 zeros and 8 and then 100. So this is going to be 100 and 8 and 4 zeros. 1,400 times 100, well, that's just going to give up, negative 140,000x. 7,200 times 25. 7,200 times 25 is going to give us 180,000 x. And we're going to get negative 25 times 100, which will give us negative 2,500x squared, because x times x is x squared. So if we finish this off, we're going to have negative 2,500x squared. This is going to give us plus 40,000x, and that's going to give us plus 10,080,000. Yeah. Okay, so that's our equation for this situation. Huge numbers. Most of you are looking at these huge numbers going, what? You're crazy. How am I going to work with those big numbers? I can't possibly do that. Well, that's why we've got our calculator. That's why we're going to use our calculator to help us solve this particular situation. Now it says determine the package of season tickets which would generate the maximum revenue. Anytime they're asking for a maximum in a question, They're actually asking for the vertex. That's a way of asking that. So what we're going to have to do is we're going to have to graph our equation to start with to be able to solve this. So it's negative 2500 x squared plus 40,000 x plus 10,080,000. Okay, so double check. Make sure you got the right number of zeros in 40,000, the right number of zeros in 10 million and 80,000. Now, absolutely, when you look at these numbers, you know this is a real world problem. We cannot possibly come up with our window settings just by hitting zoom 6. So we're going to have to use a table of values to help us come up with our window settings. Now, the x-axis in this case is actually related to the number of $25 increases. It's also related to our price. So the absolute lowest price that we can charge is 0. Now, it doesn't make sense to go up by increments of $1 at a time. The original price was $1,400 for these tickets, and we know it's either going to be more or less than $1,400. So I'm going to suggest that we go up in increments of 100 here, like 1,400, 1,500, 1,600, or 1,400, 1,300, 1,200, etc. And we're going to hit second function graph, and now we're going to look at a table of values. You're going to notice that there's a whole bunch of negative values here. Why is our revenue, how much money we're going to make? So we definitely do not want to make negative money in this case. Why are all those negatives? Let me double check my equation. Negative 2,500 x squared plus 40,000 x. Oh, hold on. X is actually the number of $25 changes in the price. So we're going to start at 0 and go up by 1. Yeah, we'll do that. Let's take a look at our table of values here. So we've got some maximum revenues here. It looks like they're all the same, but if I actually go into my calculator and I actually go to the y-axis in my table, I'm going to notice that these things are actually different. They're actually not the same. It doesn't look like our revenue's changing a lot when we're going by 1. So we're going to go back in, we're going to start our table at 0, and we're going to change by 2 instead, and go second function graph and look at your table of values. Oops. Looks like our revenue is about the same. Oh, it's starting to go down around 22, 24, 26. Okay, so I'm going to suggest we go from 0 to 30 for our X window settings. So we're going to go back here. We're going to type in our X window settings, 0 to 30, and we're going to go by 2s. And then we've got to type in our Y window settings. Well, the Y minimum here is about 9,030,000. And the Y maximum, if I start scrolling along here, Y maximum is going to be somewhere here in the middle. Looks like it's about 10,240,000. I'm going to make it 10,300,000 for our Y maximum. So we're going to go into our window. We're going to make X 0 to 30 going by 2s. We're going to make Y 9,030,000 and Y maximum 10,300,000. And we're going to go by 100,000s in this case. And we're going to hit graph. We're going to see, oh, we got a pretty good graph. So using the table of values helped us make a really good graph. Now it says determine the price of the season tickets that would generate a maximum revenue. So we've got to find this vertex, this maximum point. So remember, to do that, we go second function and trace, and we choose number 4 for maximum. And when it says left bound, we've got to move our cursor till it gets over on the left-hand side of our vertex somewhere. All right, so I can see it now. It's somewhere over here on the left side, and I'm going to hit enter. Right bound, I need to move it back to the right using my right arrow, and I need to move it somewhere on the right-hand side. There we go. I can see it on the right-hand side. That nasty guess again that I absolutely hate. Don't know why it's there. If I wanted to guess, would have done it a long time ago. Hit enter, and it's going to tell us some information. 7.999999895 is essentially 8, and this is 10,240,000. So let's go back to the question. It says determine the price of a ticket package that will give you a maximum revenue. Well, it tells us X is 8 in this question. Well, if we go back to our original question, we said the cost is 1,400 plus 25X. So if we figure out the cost of a ticket price, it's going to be 1,400 plus 25 times 8, because you're going to have 8 increases of $25. 8 times 25 is actually 200, and 200 plus 1,400 is going to tell us the maximum revenue is going to happen when you have $1,600. The actual maximum revenue was $10,240,000. Next question says, how many season ticket holders would there be if this plan was implemented? Oh, we want to know the number of ticket holders. So we got to go back to our number equation. It's 7,200 minus 100x. In this case, x is 8. So we're going to have 7,200 minus 100 times 8 is 800. So 7,200 minus 800 tells us we're going to have 6,400 ticket holders. Last thing it wants to know is how much more revenue would be generated if Plan C was implemented. So we want to know original revenue and new revenue, and we want to know how much more was actually generated. So in the original plan, we charged $1,400 per ticket, and we had 7,200 ticket holders, so that gave us $10,080,000. In the new plan we're proposing, we're going to have charge $1,600 a ticket, have 6,400 ticket holders, and make $10,240,000. And if you subtract these two things, it shows us we're going to actually make, even though we have less season ticket holders, we're actually going to make $160,000. So there is a realistic problem. People who run sports teams, who run theaters, who run events, they want to generate maximum revenue from their event, and they need to know how many people they need to get in the door and what price they should charge to generate that maximum amount. So if you're going into business, you may be using quadratic functions to help you solve some problems and look at maximum revenue. When you get a problem similar to this in your assignment, make sure you go back to this problem and use it as a model to help you try and solve a particular problem.